All right, so continuing Notes 13.1. So this time we're looking at domain. So I want to look at all the possible x values for this. So when I'm looking at this, I got to kind of think of what's going on. So good thing I already have this guy graphed, and I can kind of see what's going on. So I know that it's only going to go so far on each part of these. Well, if I'm thinking about launching something in the air and I'm looking for those degrees, where do I have to start those degrees at? 0. So this one's going to start at 0. And it's going to go from there. And then it's got my x values. Because I can go straight up into the air on it. So I can go all the way on. Now, I got to figure out my greatest x value. So all the way over here. Which means I'm finding an x-intercept. So doing that, I want to take and zoom out just a little bit. Because I got to be able to see it to find it. I'm going to zoom. Of course it's not. Do one. Oops. Grab it. Okay, we should be able to find it. Second, trace, 0. I want to make sure I'm to the left. Yep, somewhere to the left. Keep on going, even though it's off screen. Now I know that I'm somewhere to the right. Enter, enter one more time. There it is. So then I have my x values at 87.4. Now, why did I use an inequality versus just listing out 20, 30, 40, 50, 60, 70? Do I have degree measures that are in between those numbers? I sure do, which is going to make it continuous. So I want everything in between those. Now, you might have an answer choice that's a little bit different than your domain, and it might say something like 90 degrees, but that's close to what you have, which means that's going to be what you're going to use. Okay, oops. Last question. Table shows the average sale price of a house after the years since 2000. So when I'm looking at these numbers, this is actually 2000, 2002, 2004, 2006, 2008, 2010. So we're looking at since 2000. Okay, so looking again at finding those points, and man, I always like to be able to see this. If I'm looking at a number and I got an x value that's 0, that means that number has to be my y-intercept. I love finding those pretty points like that. Now, since it's a scatter plot, I might not be exactly that, but it's going to be really close. So let's answer these questions. What is the average sale price, which is P, for something in the year 2002? Now that's 2 years since 2000, so that's where they get that T value that's equal to 2. Oh hey, there's T. Guys, circle that right there. What's the average sale price since it's been there? 144. Now, that's not just 144, that's in thousands, so it's $144,000. Okay, which of the functions is a best fit for this data? Circle one. Well, here's the thing. Didn't we just talk about a y-intercept? And if I've got my equations in standard form, the way those are, then that y-intercept is also going to be my c value in my equation. So if I look at that, 9 is nowhere close to 165. So I know for sure that one is gone. But after that, I'm going to have to go look at my actual part. And I can already see that I have an approximate value down here. So I'm not only am I going to try to find this equation, but I'm also going to store that equation to use it later. So I'm going to stat, edit, and I'm putting in my new numbers. So up, clear, enter, and then go over, up, clear, enter, and I can put in my new stuff. 2, 0, 2, 4, 6, 8, 10, 165, 144, 120, 115, 128, and 165 again. Ooh, I'm even noticing here I've got symmetric points because both of those are 165. Interesting. So that means that it went down and then back up, which actually tells me that this is going to be something that's down and the back up, which means, oh, it's going to have a minimum. Let's see if we're right. So we're going stat, calc, and if I look at my answer choices, all of them are squared, so I'm not even going to waste my time with linear. I'm going straight to quadratic. So stat, calc, 5. I want to store this, so I go down to store regression equation, alpha, trace, y1, enter, and then enter on calculate. All right, and there it is, and I got that really strong y value on there as well. So they've got an a value of 1.9, which is going to round to a positive 2. So not that one, and not that one. Let's check the rest of it, though. Of negative 20.3, and then 169. Yeah, that's super close to what they've got there. They just kind of rounded off to the nearest whole number. Awesome. So now, when they're going to find the approximate value of it, I got to think about this like a point. Because right now, my calculator knows x, y. So did I think of which one would I consider as my x value? It's going to be the t. And then p for that, because I'm looking back at my table for that. So then, what's my t value going to be if it's 2007? Well, it's been 7 years since 2000, so I'm going to look for 7. So I'm going to go check my y equals, make sure it's there, and you know what? I want to see this. So let's go zoom 9. Ooh, how pretty. And see again, it's not perfect, but it's pretty close. Pretty good. So that's why it's that approximate value of it. So then I go second, graph, and I want to see where it's at 7. So I can scroll to 7, and I get the 1.29. So let's just round it off. So 1, 2, 3. So this would be $123,000. Now, remember that you also could do second, trace 1, and enter 7, and it's still going to show up. It's going to spit out the same number, so that can work for other numbers as well. Okay, hope this helps with your homework. See y'all next time.